Hey everybody, welcome back to 6th grade science e-learning style. This is episode 10. We made it all the way to double digits. Congratulations on that. Before we get to this week's episode, another thank you to my mom for making the last episode one of the most successful in history. It received 2 likes on YouTube, which is more than any other video, which is really nice, although it does make me now feel like people like me only because of my mom. Which just reminds me of high school all over again. Just kidding, that doesn't make sense. It reminds me of middle school all over again. The plan for this episode is threefold. Number 1, we're quickly going to review the moon phases before moving on, number 2, to some new concepts about the sun. And then number 3, we're going to preview the work that is to be done Wednesday or possibly Thursday. We have another special guest helping us out with the moon phases this week. So without further ado, here we go.
Full moon. New moon. Waxing gibbous. Waning gibbous. Waxing crescent. Waning crescent. Fourth quarter. Third quarter.
That's right, my son sure knows a lot about the moon. Moving on, let's highlight a few more key concepts about the sun that have been challenging to 6th graders and other very intelligent humans during their study of astronomy. We're first going to talk about a light year. A light year, and I hope you're sitting down for this, is the distance that light travels in 1 year. So light year is indeed a distance. It's not a measurement of time, it is a distance. Specifically, it is 5.9 trillion miles or 9.5 trillion kilometers. Scientists calculated that because they measured the speed of light to be 186,000 miles per second. That's fast enough that if you could travel at the speed of light, you would go around Earth 7.5 times in 1 second. So traveling at the speed of light, the light that leaves the sun travels through space 93 million miles or 150 million kilometers to Earth in the time of about 8 minutes and 20 seconds. So the light that shines down on your face or on my naturally curly, beautiful hair has traveled through space 93 million miles in 8 minutes and 20 seconds. This picture also brings up another interesting question. Let's just point out 3 random stars. Would you say the blue star is brighter than the green star, or are they about the same? How about the green star and the red star? It's tough to judge the actual brightness because those stars are not equidistant or not the same distance from us on Earth. We can see that the blue star appears brighter, but we don't know if it's actually brighter or produces more energy. To solve this problem, scientists came up with 2 concepts that are related: apparent magnitude and absolute magnitude. Apparent magnitude, by definition, is how bright an object appears to be as viewed from Earth. That's different than absolute magnitude. Absolute magnitude is the actual output, energy output, the true luminosity of a star. So how bright an object actually is. So scientists said, let's say everything were a certain distance from Earth and then compare them. That's how they get the absolute magnitude. We can illustrate this by looking at this poor resolution picture that shows a few famous stars, including Sirius and Betelgeuse. Sirius is the brightest star in our night sky. It is actually 25 times brighter than the sun. However, the sun appears much brighter. And that's because Sirius, the star, is 8.6 light years away. So the light that hits your eye when you look at Sirius left that star 8.6 light years ago. Betelgeuse, not quite as bright, is actually 7,500 times brighter than our sun. But it doesn't appear as bright as our sun or as bright as Sirius because it is 642 light years away. So when you look up at the sky and see Betelgeuse, essentially the light that hits your eye has been traveling for 642 years. Let's recap some key points. When we think of light year, let's remember that that is a distance, specifically the distance that light travels in a year. Apparent magnitude is how bright something appears to us, and absolute magnitude is the actual luminosity or actual brightness. Speaking of the sun, let's preview tonight's assignment. So what I've created is a Keynote template available for download on Canvas. You can just snag it, open it in Keynote on your iPad. It is for a family trivia game. You're going to be the trivia host. There are 11 questions. Some of the questions have all 4 answers. You need to make sure that you know which one is correct. And then other questions don't have any answers. You need to find the correct answer and then provide 3 incorrect answers. Once you've completed the document, please share back with me your finished work on Canvas by Thursday at 4 p.m. And then have fun playing trivia with your family. Thank you. In addition to the trivia keynote, please remember to complete the CLA that's available on Canvas. You get 10 attempts. It covers all 8 moon phases and both major types of eclipses. Please take this without any resources or outside help, and retake it if you would like to improve your score. And I know you're thinking, hey, are you forgetting something? Let's close this episode with a quick lesson from Fox.
And do you want to say thanks, everybody? Bye.
I'm gonna teach you about iceberg now. So icebergs has a pointy top and more at the bottom. And this guy's worried he might fall in the water. And ice floes or flat, don't step on them. And this guy's happy so he will not fall off. Bye. See you later. Bye.